Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In this class, we will learn about principal planes and principal stresses. So, before going to principal plane, we need to draw one object. So, let's take this as our object. Okay, if we cut this object from here, so what we will have? So, our object will look like similar to this, right? Let's take the object example as watermelon. If we cut the watermelon into parts, so what happened? It will form like this type of structure. Okay. So, in case of any object, there are many forces applied here. So, here lots of forces are acting, right? So, now what happens? There will be one resultant force of all the forces we have, right? Let's take here. So, we take the point here and we have the resultant force as R here. Okay. So, these will make one angle as phi. Okay. Here it will make angle phi. As we know, if we know the directions, so our directions work like this. If this will be in x direction, this will be in y direction and this will be our z direction. So, this resultant force will make the angle phi in which direction? In x direction. Okay. So, in x direction there will be one force that we will take that as Px, right. Also here in y direction we will have Py and in z direction we will have Pz. Okay. So, to understand better, okay, we will take only one plane or one face, that will be our x plane. Okay. So, in x plane only the force x will apply. So, this Px will give us, we know that what? Our stress is force upon area, right. So, for force Px we will have sigma in x direction. Okay. So, this sigma we will name it as sigma xx. Why? As it acts first along x plane and this suffix named as like sigma xx. Why? This first x is for it acts in along x plane and this x for along x direction. Okay. So, first this we will get sigma xx in x direction. Sigma xx is our what? This is our normal stress. So, due to normal stress, also there will be some shear stress. We know that shear stresses are perpendicular to normal stress or parallel to the plane. So, now what happened? Due to this normal stress, there will be shear stress. We will take that as tau x, as it acts in x plane, it will named as tau x, and as it is acts in y direction, so it will be our tau x y. Also in x plane and z direction we will have tau x z. So, in case of what? X plane, we will have normal stress as sigma xx and shear stress as tau xy and tau xz. Okay. So, in x plane, we will have normal stress as sigma xx, tau xy and tau xz, right. Now, to know about the principal planes and principal stresses, let take this tau xy and tau xz as 0. Okay. So, we will consider the shear stress, that is tau xy and tau xz as 0. Okay. So, in case of any plane, right, if this circle is the plane, if in case of this plane, what happens? If shear stress is 0, that is our tau xy or tau xz equals to 0. So, there will be only sigma, that will be our normal stress. Here as written, if in case of any plane the normal stress only present and shear stress becomes 0, so that plane we termed as principal plane. Here the plane which have no shear stresses are known as principal planes, right. Hence principal planes are the planes with 0 shear stress. Also we have termed that as till now normal stress. In case of any normal stresses present in principal planes, we term that as principal stress. Okay, so now what happens? This plane becomes our principal plane and this sigma xx become our what? Principal stress. In case of any plane, if shear stress is 0, that we will term that as principal plane, and the stress, that is normal stress present in case of that principal plane, we term that as principal stress. Okay. Now we will learn what are the types of stress system. First is uniaxial stress system. In case of, let's take this as our object A, B, C, D. We have already known that in which directions our stress system works, like x, y and z. If we consider only one direction, that will be our uniaxial stress system. So, here sigma y, okay. In this case, the stress is acting only in one direction. So, we term that as uniaxial stress system. Also, if you want to act the stresses like in this manner, it is also okay. There is no issue. But stress is acting only in one direction. It can be like this, also it can be like this. Okay. But if in case of any object, stress is acting like in both direction, like here in x direction and here in y direction, we will term that as biaxial stress system. There is nothing much bigger things like uniaxial stress system, so stresses will act in only one direction. If biaxial stress system, stresses will act like in two directions. Okay, triaxial stress system. Till now we have done this object in two dimensional. So to know triaxial stress system, we need to draw the object in 3D form, right? So no, let's take this as our one object. Here A, B, C, D and E, F, G, H. Okay, this is the 3D object. So how we will define, like, which is our x plane, which is our y plane and which is our z plane. So to know what x plane, or you can say x face, okay, or y plane or y face, also z plane and you can say z face. So in case of, as we know, x direction is like this. So which plane cuts through which direction, we will term that as x plane or y plane. Or like we know x direction will cut this plane like in this direction. So this x or sigma xx cut the plane what? CHGD. So CHGD our x plane. Also you can say the which direction cuts the plane along the axis, that will term as that plane. Like if x direction cuts this plane, so it will termed as our x plane. Like this, if y direction cut this plane, so this is our y plane, that will our A, E, C, H. And in z direction, the front, the face, like A, C, D, B or A, B, D, C is our z plane. Okay, for better understand, you can say here x direction in horizontal direction. So horizontal direction cuts which plane, you can say that as that plane, like x axis cuts this plane, so it is our x plane, right? Likewise this front face cut by z axis, so this is our z plane. Okay, so we need to understand what is triaxial stress system. So okay, in case of triaxial stress system, there will be three stresses, that will be in x direction and y direction and z direction. So here the stresses will be sigma yy, in this plane will be sigma xs and here sigma zz. You can draw this like in this way also. Okay. Now you have understood what uniaxial stress system, biaxial stress system and triaxial stress system. Now to understand pure shear system, there will be, if shear is present here, so there will be one shear stress. Okay. So to understand pure shear stress, we will take A, B, C, D object. Okay. So, in this direction there will be sigma xx, and here we will have sigma xy. In case of pure shear system, so what will happen? Here we will have tau x y, right? So, why we named it as tau xy? As the shear stress present in x plane and y direction. So, as the reaction of this will be here, as direction is going like this, so here also the direction will be in this way. This is our what? Clockwise direction. So, here we will have clockwise direction. Also, in what? In y plane and y direction, we will have like sigma y in x direction, and this will work like in this way. So, we will have sigma y x. Okay, these suffixes are y works like in y for y plane and for x in x direction. Okay, here also tau x y, here tau x y. Okay, so we will have learn pure shear system. Now what? Biaxial stress with pure shear stress. Biaxial stress, the similar, here sigma xs and sigma yy are present. Okay, so also tau xy and tau, here tau yx. Okay, and tau yx is present. Okay, so if we have both normal and shear stress, in one object, so we will term that as biaxial stress with pure stress system. Okay. Also, if both normal and shear stresses are there, normal and shear stress, we will term that as compound stress. Okay. Here, in case of compound stress, both normal and shear stress acting on any plane strained body. Strained body is what? We are using that type of body. Okay. If there will be one tensile force, the force will act. So, what will happen? The body will form like this type of structure. There will be change, deformation of the body. So, we will take that as strained body. Okay. Also, in case of rigid body, it is not possible. So, we are taking what type of material? Like ductile material. Okay. So, if shear stress is 0, that will be our principal plane. But if both normal stress and shear stresses are present in case of any material, so we will term that as compound stress or both biaxial and pure stress, pure shear. Okay. So, we will understand this compound stress system as it is very a little bit complex than normal stress and strain. We will understand it in our next class. So, till now, thank you so much.